It's a well-known saying, nothing comes from nothing. If we now put this into a galactic context, an exciting question arises. How could the universe literally come into being from nothing? For our terrestrial lives, something can only be formed if components exist to build it. But where did the material come from that made the hour of birth of the cosmos, thus the Big Bang, possible? Together with you, we'd like to take a closer look at this profound topic today. What do experts have to say about this central question? And can it be answered at all with our current knowledge? Let's go in search of clues together. Excited about the groundbreaking discoveries and great mysteries of the universe? Then remember to subscribe to Simply Space and click the bell for regular updates on these exciting topics. Show us with a thumbs up that we can keep you engaged with the content of our videos. The end as the beginning. No matter if it's the Big Rip, the Big Crunch, or the Big Freeze, even if theories differ from one another, they all end in the same scenario, the end of the universe. If one follows these hypotheses, then one day the last star in the cosmos will burn up. Afterwards, the universe will change into a lightless place of emptiness. In that dark epoch, gigantic black holes will consume all remaining matter, before finally evaporating themselves into a final act of destruction. Space will expand until even the faint light from the evaporating gravity monsters is too dispersed to interact, and the activity of the cosmos will come to a complete halt. At least, that is a widely held view among scientists. While many researchers regard such a process as the final end of our galactic home, however, some experts recognize in it something completely different, namely the beginning of a new universe. In fact, some researchers are convinced that it was just such a dark, cold, and empty universe that was the basis of the Big Bang. However, before we go deeper into this exciting thesis, we should first address another, no less exciting question. How did the first physical matter actually come into being? If we want to explain the emergence of stable matter from atoms or molecules, it becomes clear that nothing of the sort existed either during the Big Bang or in the millennia that followed. What we do know is that the first atoms formed from simpler particles as soon as external conditions cooled enough to follow the formation of complex stable matter. We also know how these atoms later fused into the stars to form heavy elements. However, our state of knowledge does not provide any information on how something can be born out of nothing. So let's turn the cosmic wheel of time back even further. Protons and neutrons, which together form the nucleus of atoms, are considered the first long-lived matter particles in galactic history. It's generally assumed that they were created immediately after the Big Bang. Before that, however, no matter existed in the classical sense. Fortunately, physics allows us to trace the timeline back a bit further, namely to those processes that took place before the birth of stable matter. The Planck era. Within physics, that era is called the Grand Unified Theory. In detail, this theory is based on the fact that at the time of the Big Bang, 3 of the 4 known basic physical forces, namely the strong, the weak, and the electromagnetic interaction, existed in the form of a single, unified force. If we penetrate even deeper into this area of speculative physics, we see that the physical world consisted of a kind of hodgepodge of short-lived elementary particles. Among them were quarks, the building blocks of protons and electrons. The relationship between matter and antimatter was balanced. Each type of matter particle had an almost mirror image counterpart made of antimatter. If these two particles, which differ from each other only in one aspect, ever met, they destroyed each other. But how were these particles formed? In this respect, the quantum field theory says that even a vacuum, considered the prime example of an empty space, is in reality bristling with physical activity. This occurs in the form of energy fluctuations and can cause particles to appear, only to disappear again. Consequently, the vacuum of space-time is also characterized by such processes. Here too, particles seem to appear out of the proverbial void. If we stretch our central question further, we come to another obstacle. How then did space-time come into existence? In this respect, the Planck era impressively demonstrates to us that we eventually come up against insurmountable barriers with our physical theories. In detail, the conceivably short-lived Planck epoch covers the immediate period after the Big Bang. At this point, space and time themselves became part of quantum fluctuations. The problem? Comprehensively understand the Planck era, we need a complete theory of quantum gravity that unifies quantum physics with relativity. M-theory and loop quantum gravity are considered promising candidates in this regard. Here, ordinary space and time are commonly regarded as emergent. Consequently, what we perceive as space and time is in fact the result of quantum processes occurring at a microscopic level that is incomprehensible to us. Since our common understanding of space and time is no longer valid in the Planck era, our classical conception of cause and effect also reaches its limits. Nevertheless, all the theories devoted to this section describe something physical that was happening at that time, a kind of quantum precursor of space and time. Even if our understanding of causality does not apply in the Planck era, it might be theoretically possible to fathom one component of that era with the help of another. However, our current theories are not capable of handling this challenging endeavor. Before the corresponding doctrines are fully developed, we cannot make any generally valid statements about the central formation processes of the cosmos. At present, it remains to be stated that physicists don't know any confirmed cases in which something has formed from nothing. Creator, multiverse, or cycles? Since it is currently impossible for us to decipher the quantum state of the universe at the beginning of the Planck era, all theories in this regard remain highly speculative. Some try to explain this central mystery by the influence of a divine creator. Other, less religious explanations see the existence of a multiverse as the most promising approach. According to this, the cosmos would not be an all-encompassing construct, but only a tiny link in an infinite chain of other universes. On the other hand, there are the cyclic models. The corresponding theses are based on the fact that the universe is subject to a constant cycle of destruction and rebirth, an exciting approach which has a prominent supporter with the Nobel Prize winner Roger Penrose. The British physicist once led the theory of the conformal cyclic cosmology into the field. If one follows the explanations of this expert, there are striking mathematical parallels between the Big Bang and the distant end of the universe. In fact, these two states are even identical when they are brought to their limits. This circumstance led Penrose to a hypothesis which seems extremely paradoxical. It was the complete absence of matter which produced all matter in the cosmos. From this point of view, the Big Bang therefore originates from something which comes closest to the ominous nothing, namely, what remains when the matter of a universe has been annihilated by black holes that have subsequently decayed into photons. But how is it possible that a cold, empty universe corresponds to a hot, dense universe from a mathematical point of view? The answer to this question lies in a sophisticated mathematical procedure called conformal scaling. This is a geometric transformation that changes the size of an object but leaves its shape untouched. And indeed, in this way, it's impossible to scale the states of the universe so that the shapes of their space-times coincide. In other words, the hot, dense state exists because of the cold, empty state. Thus, the end of an expanding cosmos is eventually followed by a new Big Bang. The search for the nothing. Let's assume that Penrose's controversial theory is confirmed one day. Even in that case, we still wouldn't have an answer to the question of how something can come from nothing. Where does physical reality come from? How was the cycle system of the universe formed? Why does anything exist at all and not nothing? Can there be such a thing as nothing at all, if by this is meant the absence of everything? How can something exist that does not exist? As you can see, it doesn't take long before some philosophical questions creep into this exciting topic. For our video today, however, we would like to stay in the realm of physics for once. So what does science have to say about the possible background of the cycles? One approach says that there could be no physical explanation for this at all. Or it's about an endless change of repeating cycles, where the initial quantum state of every cosmos conditions the properties of the following universe. Furthermore, it's conceivable that only a single cycle exists, with the beginning of the cosmic cycle being defined by a property of its end. Who knows if we will ever get an answer to the fundamental questions of the universe? But is it not just this great uncertainty that makes the topic so compelling? Now we want your opinion. What do you think about the different views on the origin and the fate of the universe? Write us your thoughts, your suggestions, and your feedback to today's contribution in the comments. Do you want to see more interesting videos about the universe? Then take a look at the other contributions on our channel, which you can access by clicking on one of the images in the credits. Thanks for watching, take care, and we'll see you next time.